Salutation to Professor Engineer Dr. Hilmi Mokhtar, Deputy Vice Chancellor Academic of University Technology Petronas, Dr. Muhammad Firdaus Abdul Wahab, Chair of American Chemical Society Malaysia Chapter, Dr. Siti Noor Azila Zaini, Chair of Southeast Asia Global Innovation Challenge 2020. Distinguished guests, Dr. Muhammad Firshan from University Malaya, Professor John D. Holbury from Queen's University Belfast, United Kingdom. Judges, we have Dr. Stephen Lim from University Tunku Abdul Rahman, Uttar. We have Mr. Chua Jong Hui from MAPA Glove, Sdn Bhd. And we have Madam Nurida Muhammad Yusof from Petronas Research, Sdn Bhd. And participants, ladies and gentlemen. Welcome to the Southeast Asia Global Innovation Challenge SEA-GIC 2020. My name is Anis Raiha from University Technology Petronas and shall be your attending MC for today's event. Before we get things moving, let me first introduce our event today. The Southeast Asia Global Innovation Challenge is an annual innovation pitching challenge geared towards participants from Southeast Asia universities for them to present their ideas and works concerning a selected chemistry theme of the year. In conjunction with the 50th anniversary of Earth Day celebration, SEA-GIC 2020 spheres around the theme of battling climate change through chemistry, which will motivate contestants to come up with effective and affordable ways to solve global climate change issues in the area of carbon dioxide utilization, renewable energy, green chemistry, as well as green transportation and building. This event is proudly brought to you by the American Chemical Society ACS Malaysia Chapter, American Chemical Society International Student Chapter of University Technology Petronas, Fundamental and Applied Sciences Department of University Technology Petronas, and supported by the American Chemical Society ACS International. Without further ado, let us welcome our Chair of Southeast Asia Global Innovation Challenge SEA-GIC 2020, Dr. Siti Noor Azila Zaini, to give her welcoming remarks. Please welcome.
Bismillahirrahmanirrahim. Professor IR Dr. Hilmi Mokhtar, Deputy Vice Chancellor Academic University Technology Petronas, UTP, Dr. Muhammad Firdaus Abdul Wahab, Chair of American Chemical Society, ACS Malaysian Chapter, Dr. Izzat Fahimuddin Muhammad Sufyan, Advisor, ACS-IIUM International Student Chapter, Honourable Judges, distinguished speakers, respected participants, ladies and gentlemen. Assalamualaikum warahmatullahi ta'ala wabarakatuh and a very good morning to all. On behalf of the organising committee, it gives me great pleasure to warmly welcome honourable guests, judges, speakers, participants and audience in the YouTube Live to the opening ceremony of Southeast Asia Global Innovation Challenge SEA-GIC 2020. SEA-GIC is an annual competition organised by the ACS Malaysian Chapter. This year, the SEA-GIC 2020 is co-organised by the ACS-UTP International Student Chapter and the Fundamental and Applied Science Department of UTP. With the theme of battling climate change through chemistry, SEA-GIC 2020 aims to promote innovativeness among these Asian undergraduates to solve the real-world problem pertaining to the theme of the year. Despite the COVID-19 pandemic, the organising committee makes every effort to organise an outstanding pitching competition in the area related to the CO2 utilisation, renewable energy and green chemistry. Ladies and gentlemen, today 15 finalists out of 57 projects from all over Malaysia, Indonesia and Brunei will pitch their ideas. The project will be evaluated by 3 honourable judges, Associate Prof. Dr. Stephen Lim from University Tunku Abdul Rahman, Mr. Chua Jong Hui, the Research and Development Manager of MAPA Glove Sdn Bhd, and Madam Nurida Muhammad Yusof, the head of Centralised Lab Petronas Research Sdn Bhd. We are also honoured to have with us today 2 renowned speakers, Prof. John D. Holbury from Queen's University Belfast, United Kingdom, and Dr. Muhammad Firoz Khan from University Malaya, Malaysia, to share their knowledge in a topic related to the theme of the competition. Ladies and gentlemen, I would like to take this opportunity to thank the ACS for the financial support. My sincere appreciation also goes to the organizing committee of SEA-GIC 2020 and all parties involved in ensuring the success of this event. Certainly, without their hard work and dedication, this competition will not have come to fruition. I hope all participants will take this opportunity to interact and establish networking, and I wish all present the best and stay safe. Thank you.
All right, thank you, Dr. Siti Nur Azila, for the warm welcoming address. Next, we shall invite Dr. Muhammad Firdaus Abdul Wahab, Chair of American Chemical Society Malaysia Chapter, to deliver his speech. Please welcome.
Thank you, Chairperson. Professor Engineer Dr. Hilmi Mokhtar, Deputy Vice Chancellor of UTP, Dr. Siti Nur Azila Zaini, Chair of SEA-GIC or SEA-GIC 2020, a member of ACS Malaysia Chapter, Associate Professor Dr. Cecilia Devi Wilfred, the Organising Committee member, and also a member of the chapter, ACS-UTP student chapter members, our invited Dr. Ahmad Firuz Khan and Professor John D. Holbray, the SEA-GIC 2020 participants, and all the audience of this first virtual SEA-GIC 2020. Firstly, congratulations to the SEA-GIC 2020 organizers for the wonderful job in making this event a great success. I know it's not easy to get things done in the middle of this pandemic, but they managed to pull it through. Let's give a warm round of virtual applause to them. For ACS Malaysia Chapter, SEA-GIC is a very important flagship event. It has been in the running for 6 consecutive years now, and it keeps getting better year after year. Probably one of the best I have seen so far. I'm also happy to share that our student chapter members always play an integral part of SEA-GIC from the start. It is truly a program by the students for the students. Let's give another round of virtual applause to ACS-UTP student chapter for all their efforts. This year, the chosen theme is very timely, which is battling climate change through chemistry. Climate change, as we all know, has been attributed to play a role in many catastrophic events we are seeing, including the current devastating COVID-19 pandemic. At ACS Malaysia Chapter, we believe that chemistry can play a fundamental role in the mitigation of the impacts of climate change. Chemistry can actually help us to understand, monitor, protect, and improve the environment around us. I'm very excited to see what our participants have to offer this year. It actually gets more and more competitive year after year. But please remember, whoever wins, you all have played your role in promoting chemistry and chemical sciences to the public. Most importantly, have fun. Thank you.
All right, thank you, Dr. Muhammad Firdaus, for the inspiring speech. Moving on, we would like to invite Deputy Vice Chancellor Academic of University Technology Petronas, Professor in Senior Dr. Hilmi Mokhtar, to grace the opening of SEA-GIC 2020, theme Battling Climate Change Through Chemistry. Please welcome.
Thank you, Farah. Assalamualaikum warahmatullahi wabarakatuh. Yang berusaha Dr. Muhammad Firdaus Abdul Wahab, Chair of American Chemical Society, ACS Malaysia Chapter, honorable judges, distinguished speakers, respected participants, ladies and gentlemen. Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera and a very good morning. How is everyone? I hope that all of you are fine, healthy and safe, staying safe wherever you are. Thank you for tuning in, and to all the participants and delegates, it is a pleasure to have your support and your virtual presence. On behalf of Institute Technology Petronas UTP, welcome to Southeast Asian Global Innovation Challenge or SEA-GIC 2020. This year, UTP is proud to be the host of Southeast Asia Global Innovation Challenge, organized annually by American Chemical Society ACS Malaysia Chapter. This challenge is an excellent platform for knowledge sharing, intellectual discussion, and also networking on our shared areas of interest for academics, researchers, scientists, interest group, and industry experts from all over the world. I'm happy to note that more than 135 participants are taking part in this event, with half of the total involvement from neighboring countries, Indonesia and Brunei. Thank you for the support. I would also like to take this opportunity to acknowledge the full sponsorship by the American Chemical Society International for this event. In spite of the unprecedented times that we are in, I'm delighted to convene here in promoting innovativeness among the undergraduates from Southeast Asia to address the ever-challenging global issue on the current time, climate change. Greta Thunberg, the Swedish environmental activist, says, right here, right now is where we draw the line. The world is waking up, and change is coming wherever you like it or not. The challenge is timely as it encourages the participants to stage interesting interactive scientific demonstration and showcase to spark curiosity and interest in climate change. Appropriately teams battling climate change through chemistry, I look forward to the practical and affordable ways to solve this global issue. The presentation will be evaluated in terms of the viability of the solution, cost effectiveness, impact of the project, and ability for industry scale up by distinguished judges from industry and academia. Therefore, we can find out students to follow scientific processes, closely asking questions, designing experiments, testing ideas, logging data, and making conclusions of findings. These steps are central to success in many different areas of science, technology, and engineering, and maths or STEM. The critical thinking, problem solving, and communication skill that all that you have developed during your project are also important foundation skill for future careers. It is important to note that these skills are already in high demand and will become more and more essential for the jobs of the future. Ladies and gentlemen, we need more young people, the future leaders, to be on board and advocate for issues on climate change. This is also in line with the Sustainable Development Goal SDG 13, which aim to take urgent action to combat climate change and its impact. Through your participation in the SEA-GIC, we are answering this call to 1. Strengthen resilient and adaptive capacity to climate-related hazard and natural disaster in all countries. Second, integrate climate change measures into national policies, strategies, and planning. And lastly, improve education, awareness raising, and human and institutional capacity on climate change mitigation, adaptation, impact reduction, and early warning. As climate change becomes a global emergency, it is my hope that we can put our brains together to provide significant inputs on finding in the solution to restore the conducive climate for livings to continue thriving. We are in Southeast Asia, like any other developing region, need to take urgent action to adapt the climate change, build resilience, and minimize the cost of the unavoidable impact of GHG emission already locked into the climate system. Together, we should set realistic and achievable goals, binding emission limits, which will create new markets for new technologies and new ideas that will, in turn, expand the boundaries of possible and create new hope to the aspiration of the Kyoto Protocol. Ladies and gentlemen, in closing, I wish to thank again the organizing committee for inviting me to deliver this officiating speech. My heartiest appreciation to our partners from American Chemical Society, ACS, Malaysian chapter, and to everyone today for the support. Without further ado, in the name of Allah, the most gracious, the most merciful, it's now give me a great pleasure to officiate the South Asia Global Innovation Challenge 2020. Wishing SEA-GIC 2020 the best. Until next time, please stay safe and take care. Thank you. Wabillahi taufiq. Assalamualaikum warahmatullahi wabarakatuh.
All right, thank you, Professor Engineer Dr. Hilmi Mokhtar, for your presence and support for today's event. Moving on to the technical briefing, before we begin our first pitching session from our finalists, let me brief on the technical rules and information throughout the pitching session. Number one, the assigned presenter from each team is required to request control over the presentation upon starting their pitching session. And time allocated for each team presentation is 10 minutes and followed by a 5-minute question and answer session at the end of it. And number three, please be noted that presenters may only start their presentation after the first bell. During the presentation, another bell will be rang on the 8th minute, followed by 2 bells on the 10th minute, signifying the end of the presentation, and another 2 bells will be rang signifying the end of the Q&A session. All right. The pitching session will start with the first 5 groups. All right. Now let us welcome team SG20A056 from Halu Oleh University to pitch their project. Please welcome.
Okay. Assalamualaikum warahmatullahi wabarakatuh. Good morning to everyone. Good morning to the judges, and good morning to the finalists of SEA-GIC 2020. First of all, we would like to thank Allah Subhanahu wa Taala, who has always give us health, opportunity, and strength to be able to take part in this activity. And we don't forget to thank SEA-GIC committee for entrusting and giving us the finalists of SEA-GIC 2020. And thanks also to our supervisor, Madam Erhab Fitri Pradila, SFA MSc PhD, for guiding us to this tech. Okay, before we do the pitching presentation, we would like to introduce ourselves. My name is Aditya Rizkan, and my partner Suryati Amiruddin and Rahmatata Pratama. We are from Indonesia, especially in Southeast Sulawesi province. We are students of Halu Oleh University, majoring in Food Science and Technology Department of Agriculture Faculty. And then we will present our paper under the title of Development of Hydrophobic Bioplastic based on sago waste, metrocylon sago rock as food packaging. Plastic waste. The main environmental problem in the world is plastic waste. In the world, more than 3 million tons of plastic were consumed in 2015. A half of that plastic production is spread across Asia. Plastic production in the world will continue to increase along with the increasing number of population in the world. Plastic industry has several drawbacks related to economic and environmental problems. What are the impacts of plastic waste? The first impact is garbage crisis in landfill area. Why that? Because the proportion of recycled plastic waste is very low. Various programs and campaigns such as 3R, namely the reduce, reuse, and recycle, have been carried out for a long time to overcome this. But still the problem of plastic waste is not found the right solution to handle it. And then, what the impact, the second impact of the plastic waste to marine ecosystem? As many as 46,000 tons of plastic float in a first square mile of the ocean. In the depth of plastic waste in the Pacific Ocean, such as almost 1 million meter. This plastic causes death marine organisms. It's estimated maybe 1 million seabirds die every year. In the third impact of plastic waste, emission of toxic gas from combustion. Toxic emission, such as carbon dioxide and methane, result from the burning plastic. These greenhouse gas have a negative impact on climate change in around the world and very dangerous to our life. The fourth impact of plastic waste, non-degradability. It is known that plastic is not biodegradable and survive in the environment for thousands of years. And the end of impact of plastic waste, petroleum is becoming scarce and expensive. Why that? Because fossil fuels as raw material for making plastic is more expensive and will be increasingly unstable. Biodegradable plastic. What is the bioplastic? The bioplastic. Biodegradable plastic, or also known as bioplastic, is plastic that can be degraded naturally. What is the function of bioplastic? Bioplastic can be used as a conventional plastic. What is the efficiency of bioplastic? Bioplastic has a low hydrophobicity, so usually broken when interacting with water. What the potential sago waste as food packaging? Sago plants in Indonesia are the largest in the world. More than 85% of the world's total sago area is located in Indonesia, especially in Papua and West Papua, with a total sago land area of 5 million and 5,000 hectares. Form of sago waste is 75 to 83% and has not been processed optimally. Sago waste contains cellulose of 20% of 100 grams of dry waste. Based on the cellulose content found in the solid waste, sago industry has the potential as the source of cellulose, which can be used in the manufacture of nanocrystalline cellulose to be used as raw material for development of bioplastic. Okay.
How to make and develop hydrophobic bioplastic based on sago waste nanocellulose. First step is sample preparation. Sago waste was separated from the sago flour processing industry in South Konawe district, Southeast Sulawesi. The dregs of sago are dried and blended to become a powder with a size of 80 mesh. The second step is extraction of cellulose. 25 grams of sago dregs flour was soaked in 750 ml of natrium hydroxide for 1 hour at 100 degrees Celsius. Then, the solution was separated from residue. The residue was washed with aqueous 3 times, then bleached with hydrogen peroxide 2% for 2 hours at speed of 180 rpm. Then washed again with aqueous. The third step is nanocellulose isolation. Tempo solution was freshly prepared by mixing 0.2 gram of natrium bromide and 0.04 gram of tempo in 100 ml distillated water. Bleached sago specimens were added to the solution under stirring. Then, natrium hypochlorite in water was added to the mixture and allowed to react for 3 hours under stirring. At the end of 3 hours, 5 ml of ethanol was added to stop the reaction. The resulting sediment was then put into a dialysis membrane bag and soaked with distillated water for 1 day. And fourth step is bioplastic production. Nanocellulose, glycerol, and aqueous were blended and dried by oven. And then the bioplastic was coated by beeswax. The coating process was carried out by immersion method. The resulting bioplastic has water repellent characteristic, more transparent and stronger.
What are the benefits of developing bioplastic? First benefit we can get is we can empowering waste. Sago is quite abundant in Indonesia with a production of around 1,600 tons in 2015. Sago waste can be obtained from the sago starch processing industry. In the process of processing sago into flour, about 75 to 93% of the raw material is solid waste from sago pulp. This waste diversification can reduce and power industrial waste of sago waste. Second benefit we can get is we can reducing the use of plastic waste. Bioplastic have a characteristic similar to synthetic plastic. It's just that bioplastic are more easily broken down by microbes, so that plastic waste will be reduced and easily recycled by microbial activity. Next benefit we can get is we can increase company revenue. A new industrial source flour processing companies produce a large amount of the waste at the time of production. Empowering this waste into diversified product like bioplastic that is environmentally friendly will add a new industrialization and will increase the company income beyond sago starch production income. Along with new industrialization source, we can supply a new workforce. Indonesia is a country with a large number of unemployed people in the world, which is around 6.88 million. The existence of new industrialization or new economic center will solve the problem of the high unemployment rate in Indonesia. Optimizing the employment of waste into diversified product will be sourced on new jobs that supply a large number of workers. And the last of benefit we can get is we can be a hero of nature. Companies that develop a diversification of environmentally friendly waste-based bioplastic product will become heroes for the environment because bioplastic product will be a solution to environmental pollution in Indonesia and in the world.
All right.
Thank you.
Okay, thank you, Group SG20A056. It was such a brilliant solution to reduce the consumption to actually option for biodegradable plastic. Let's welcome Team SG20A009 from University Technology Malaysia to pitch their project. Please welcome.
The Earth is healing. COVID-19 global health crisis does not only affect the lives of millions of people. The quarantine measure implemented had severely affected countless industries, inhibiting world's economy. As a matter of fact, in the last few months, there is a significant reduction of carbon dioxide emissions, with new adaptation of work-from-home policies also played its part. The Earth is healing, but is it economy-wise? The United Nations Framework Convention on Climate Change, Kyoto Protocol, and Paris Agreement under United Nations all had the same goals: to enforce the global response to the threat of climate change. The IPCC 2014 reports implied that there are two of the highest global carbon dioxide emissions are from energy production and the industrial sector. This alone contributes to 46% of global gas emission. The demands of fossil fuels cause an enormous price for the Earth to pay: extinction. It leads all the way to water pollution, air pollution, and last but not least, climate change. It is inevitable, but without mitigation approach, impacts are likely to be more adverse, thus adaptations are impossible to be achieved. Therefore, we introduce you an engineered innovation of biomass pyrolysis in climate change mitigation. We believe that greater goods can be achieved by imposing a new technology framework that enables to reduce the threat of climate change and align with the Sustainable Development Goals, as well as promoting the mitigating response to facilitate Malaysia's national biofuel policy to foster the economic growth.
Biomass is renewable organic material that comes from living organisms, including plants, animals, and microorganisms. From a biochemical perspective, cellulose, lignin, sugars, fats, and proteins. So, what is biomass pyrolysis? Biomass pyrolysis is a thermochemical decomposition of biomass process in the absence of oxygen operated at higher temperature. usually at 300 to 700 degrees Celsius to produce solid biochar, liquid bio-oil, and syngas in an inert atmosphere. Biochar is a black, highly porous, lightweight, and fine-grained charcoal-like substance in a stable form of carbon that cannot easily escape into the atmosphere. Bio-oil is a dark brownish viscous liquid that bears some resemblance to fossil crude oil. It has a composition of complex oxygenated compounds comprised of water, water-soluble compounds such as acid and ester, and water-insoluble compounds, usually called pyrolytic lignin. Syngas, or synthesis gas, is a fuel gas mixture consisting of primarily hydrogen, carbon monoxide, and carbon dioxide. Syngas is combustible and can be used as fuel of internal combustion engines. The two main classes for biomass pyrolysis are fast pyrolysis and slow pyrolysis. In this process, we focus on slow pyrolysis of biomass as it can produce more carbon-rich biochars intended for agricultural use with reliable and consistent product qualities than fast pyrolysis that yield more bio-oil. It is carried out at atmospheric pressure, and the process heat is typically supplied around 400 degrees Celsius. It is characterized by slower heating rate, relatively long solid and vapor residence time. During the pyrolysis process, the natural polymeric constituents such as lignin, cellulose, fats, and starch are thermally broken down into three different fractions, which is 35% biochar, 35% syngas, and 30% bio-oil. Depending on the heating rate temperature, different distributions and yields of the aforementioned fractions can be obtained.
Pyrolysis provides a lot of Joseph. There are three main areas where the adoption of pyrolysis and biochar systems may bring benefits. These are agricultural soil improvement, waste management, and renewable energy production. The biochar is sufficiently stable to reduce greenhouse gases in the atmosphere for an appropriate length of time. Slow pyrolysis produced higher percentage of biochar, where more CO2 can be locked in the form of solid to be used as soil modifier along with fertilizers. According to Lehman and Joseph, addition of biochar to soils can enhance fertility, leading to increased crop yields by 140%. This also allows for the reduced application of energy-intensive agrochemicals. According to Lehman and Joseph, judicious biochar management may contribute to both strategies, which are reduction of emissions by agriculture and active withdrawal of atmospheric carbon dioxide. In addition, char produced by pyrolysis can be used as a renewable fuel. It can be used directly or co-fired with other solid fuels in conventional generating plants. According to Kamen and Liu, traditional charcoal making processes are often inefficient and are seen as a major source of environmental degradation through deforestation and pollution in rural areas. The use of pyrolysis technology at appropriate scales is a good way to improve efficiencies and sustainability, thus reducing biomass requirement for the same charcoal output. This process can also be an alternative energy source because it produces bio-oil and syngas. Liquid and gas co-products of biomass pyrolysis can be used for electricity generation as well as being used to power the process itself, thereby offsetting fossil fuel consumption. Biomass can simply be burned to raise steam, thus generating electricity and usable heat. However, greater efficiencies and value can potentially be achieved by incorporating a pyrolysis step. According to Thornley et al., efficiency of biomass energy conversion to electricity by direct combustion is 25 to 30%. However, by using a pyrolysis process and combined cycle gas turbine technology, the conversion efficiency may be increased to 35 to 40%. Dynamotive suggests that the liquid can be upgraded to produce higher value products suitable for use as transport fuels. They et al. States that pyrolysis can be used in combination with a steam reforming step to produce hydrogen for fuel use. In some of these uses, a benefit also rises from concentration of energy value into a lower volume products, which reduces transport emissions and costs if conversion facilities are appropriately sited.
Allow me to briefly restate these important points we just talked about. We witness how the emergence of fossil fuel ever since the Industrial Revolution, yet we seem to be blindsided by the overwhelming effect it has caused today. Our verdicts remain the same, that we believe biomass pyrolysis is the answer to take the mitigation approach to the whole new level without a doubt. India, as the 7th largest country in the world, shows the potential of pyrolysis technology to be used as biowaste treatment. Evidently, we show you the potential of pyrolysis not only for soil nutrient enrichment, but also all the ways from providing a carbon pool to the soil, a potential to be scaled up on industrial application for energy and heat generation, as well as an alternative for biowaste treatment, which all this leads to climate change mitigation. What is required are practical phase application and demonstration with appropriate calculation of material and energy balance. Biomass pyrolysis will be a good measure to reduce the dependency on fossil fuels as well as producing valuable products with lesser impacts to the environment. The demands of fossil fuels does not only harm the environment, the depletion of fossil fuels is also possible, and it's a matter of time on how long till we run out of this unsustainable energy source. Not only it kills two birds with one stone, this concrete proposition is well aligned with United Nations objective of Goal 7 and 13 of UN SDG to achieve net zero carbon emissions by 2050. Yes, we can't get it through a single day without having an impact on the world around us, be it good or bad. Our actions make a difference, and the choice is in our hand to decide the kind of difference we want to make. That is all from us, the representative from University Technology Malaysia. I am Muhammad Mazdi bin Jimmy Moreno.
My name is Muhammad Shami Asnawi.
And my name is Nazmi bin Muhammad. Thank you very much.
And now we shall move on to Team SG20A002 from University Science Malaysia to pitch their project.
Good morning, everybody. Alright. We are from the School of Chemical Sciences, University Science Malaysia, and we are final year students. The title of our project is the conversion of dissolved carbon dioxide into electrical energy using an electrochemical method. I am Shirley Unishan, and my group members are Ku Kuiling and Chai Jia-en.
So the vast industrialization associated with the rapid acceleration of human population has led to the release of carbon dioxide in the environment. Carbon dioxide is the greenhouse gas, and the increase of carbon dioxide emission has around widespread concern in the global due to their side effects. Human activities such as deforestation will increase the concentration of carbon dioxide in the atmosphere. And interestingly, global average amount of carbon dioxide hit a new high record in 2019, which is around 409.8 ppm. So here we show the process of transformation of atmospheric carbon dioxide. First, the carbon dioxide in the atmosphere will dissolve in the water bodies, and seawater will be what we focus on because seawater is the largest water reservoir in the world. So the dissolved carbon dioxide will first convert to carbonic acid, and it will further dissociate to bicarbonate ion as well as hydrogen ion. And these are our objectives in our study. And first, we will compare the efficiency of platinum as well as copper as the cathode. Furthermore, we will also study the efficiency of 3D printed electrochemical cell. And finally, we will investigate the presence of dissolved carbon dioxide in seawater.
We started our project by collecting seawater and lake water samples, followed by filtering them with filtered paper. Then, we carry out electrochemical process by using the ionized water, lake water, and seawater as electrolyte in glass heat cell. And we found that the seawater has produced the highest voltage. So, we conducted the cyclic watermetry on the seawater by using sodium bicarbonate and phosphate buffer as the control. Next, we carry out electrochemical process in our 3D printed cell. We are accessible to 3D printing machine in our own lab. So we created our own 3D printed cell by using a transparent PLS filament. We also use two different types of metal cathodes, which are platinum and copper. to compare the efficiency in the electrochemical process.
Here is our 3D printed cell that we have printed. With the fourth industrial revolution coming up and booming everywhere around the world, everyone and anyone can literally design, print, and assemble whatever they want just like that. 3D technology provides chemists with the ability to design, prototype, and print functional devices. Compared to common laboratory hardwares, which needs constant maintenance due to usage and breakages, we have opted to use and to print our own electrochemical cell, which can be easily replaceable in case of any malfunctions. Here we can see that we have used a simple aluminum foil as our anode and table salt or sodium chloride as our electrolyte at the anode. The aluminum ionizes into aluminum ions, and at the cathode we have used platinum or copper wire as the cathode, and the electrolyte is simply just seawater. Hydrogen ions are discharged as hydrogen gas here. As for our salt bridge, we have used potassium chloride salt and cotton wool as the membrane. Surprisingly, wool separates the electrolytes very well. Finally, we connected our electrodes to a potentiometer to finally get our results.
The first table here shows the cost without considering the cost of the cell. The main difference here is the cost of the platinum electrode and copper wire. It costs us 4,000 ringgit Malaysia if we use platinum electrode. However, it only costs us around 3 ringgit Malaysia if we use copper wire as the cathode. Nevertheless, platinum shows higher efficiency, which will be discussed later. The second table shows the comparison of the cost between a 3D printed cell and a glass head cell. It only costs us 2 ringgit Malaysia if we use a 3D printed cell. However, it costs us 1,500 ringgit Malaysia if we use a glass head cell. Again, here is a big difference. Here we would like to shortly present our results obtained from our experiment. Since the seawater has produced the highest voltage, we focus only on the seawater. The combination of a 3D printed cell and a platinum electrode has produced the highest voltage, obviously. On the other hand, the combination of a glass head cell and a copper electrode shows the lowest efficiency in the electrochemical process.
Okay, so we would like to present our data in a different way, which is using a bar chart. Here, let us compare the different electrodes, which are copper and platinum, while using our glass H cell, which was our original idea. Here we can see that there is somewhat higher potential produced by the platinum electrode compared to the copper electrode. And next, let us compare between the two different cells, which is the commercial glass H cell that we have to buy from supplier and our 3D cell that we have printed at our lab. From here, using both copper and platinum as electrode, we can see that there is anyway a higher voltage produced by the 3D printed cell in red. Finally, let us compare again the different electrodes used for a 3D printed cell. From here, we can see that it is proven the combination of a platinum electrode and a 3D printed cell is the most efficient electrochemical cell in converting carbon dioxide into electrical energy. Next, we also conducted a cyclic voltammetry to prove the presence of bicarbonic acid, which fundamentally came from carbon dioxide in seawater. Here we use two controls. Which are in blue and green, where there is no reduction peak for phosphate buffer and there is reduction peaks for sodium bicarbonate and seawater. Our solutions are constantly and continuously purged with nitrogen gas to remove the solution from oxygen, which can also provide another reduction peak. So you can see here, this is the reduction peak for bicarbonate ions, proving that seawater indeed contains bicarbonate ions. The larger reduction peak proves that seawater has higher concentration of bicarbonate ions than 0.1 molar sodium bicarbonate. And the reduction peak is also more positive than sodium bicarbonate, proving that it is more acidic than our control. Now, we can relate that the higher concentration of bicarbonate ions has given rise to the more acidic pH of seawater.
We strongly believe that our 3D printed cell biosynth seawater as electrolyte has a wide range of applications. It can be used to design a small-size portable generator for fishermen at sea. It can also be used to develop a simple and economical carbon dioxide sensor. Moreover, the hydrogen produced at the cathode can be used in the hydrogen fuel cells, where these fuel cells functions as batteries for electronic devices and power sources for vehicles and spacecraft. In fact, hydrogen fuel cell vehicles will result in cleaner air. As for large-scale applications, power plants can be built by using seawater. It will reduce the amount of atmospheric carbon dioxide as well as reduce the pH of the seawater to prevent ocean acidification. The benefits of 3D printed cell by using seawater as electrolyte include the utilization of the excess resource carbon dioxide in seawater, and most importantly, carbon dioxide is not regenerated. Besides, it's a simple approach to produce electrical energy by using electrochemical methods. And last but not least, the highlighting point of our project is that our electrochemical cell is fabricated by a 3D printing, which involves only very low cost.
So in line of helping people around the world, we can optimize our electrochemical cell and put our 3D model on the internet so anybody can print it at anywhere in the world.
We would like to gratefully acknowledge all the parties above that helped us making our project a success. Thank you very much.
Right, that signifies the end of your presentation. That was a very brilliant idea. Like we have 3 groups presented already, and I think we are ready for the next team. So I shall call for group G20A020 from Swinburne University of Technology Sarawak campus to pitch your project.
A very good morning to the honorable judges, fellow contestants, and audience. We are Team A020 from Swinburne University Technology Sarawak, Malaysia. My name is Eng Shiyen and my teammate is Ong Jaling. Today, we would like to present our topic entitled The Future Paradigm of Hydrogen Production via Catalytic Dry Methane Reforming. This is the overview of the presentation. I will cover the first 3 sections, while Jaling will discuss the last 3 sections, starting from project outcome up to the future prospect. So nowadays, global warming has been a hot issue. It raised more and more people's attention, especially some scientists, to obtain sustainable and renewable energy. On the other hand, global demand for hydrogen in pure forms has grown steadily over the past 50 years to around, and it is predicted to be the major energy source in the future. Hydrogen can generate electricity and produce chemicals like ammonia, methanol, and renewable diesel. Due to the emerging technology of hydrogen cars, hydrogen has substantially replaced the use of petroleum in vehicles. And therefore, a dry methane reforming process is proposed. Dry methane reforming can convert methane gas and carbon dioxide, which are considered as greenhouse gas, to produce carbon monoxide and, most importantly, green hydrogen. You may have a question on what feedstock can produce green hydrogen. I would like to say is biogas. Biogas is produced from palm oil meal effluent. The palm oil meal effluent is processed through an anaerobic digestion, which eventually produces biogas with methane and carbon dioxide. By using biogas as feedstock in the hydrogen production, it aligns with the waste to wealth concept, and therefore the hydrogen produced is called green hydrogen. Our topic mainly covers carbon dioxide utilization with a dry methane reforming process to produce hydrogen, which is considered as one of the renewable energy, and also green chemistry by utilizing a catalyst in the process. These are the problem statement and objectives of our topic. We aim to address the drawbacks of conventional nickel catalysts, such as serious sintering and deactivation, the intention of novel catalysts, last but not least, the economic and environmental performance of the novel catalyst-based dry methane reforming. This research project involves data collection to collect all relevant data. This data will serve as the input to the later formulated simulation model in Aspen Plus. An economic analysis will be performed to evaluate the material cost and energy cost of the process. Lastly, an environmental analysis of catalytic DRM will be performed to identify the carbon footprint of a catalytic dry methane reforming produced. The research group has carried out a comparison case study between nickel-based catalysts. To prove the feasibility of the novel catalyst in dry methane reforming process, the research group has benchmarked the performance of nickel-based MOF catalyst, single-atom catalyst, and the conventional catalyst, which is on alumina. The MOF-based catalyst is nickel-supported on MIL53, whereas the single-atom catalyst is nickel-supported on HAP. Now, I will pass the floor to my teammate, Jialing.
Thank you, Chien. For economic analysis, the information of the amount of raw materials required to synthesize the catalyst is collected and used to calculate the material cost for 10 kilograms of catalyst respectively. Next, the operating cost of the catalyst synthesis process is also taken into account, such as the cost for energy and water consumption. However, the operating cost is relatively small as compared to the material synthesis cost. It can be clearly observed that the total synthesis cost for nickel MIL53, a MOF-based catalyst, is significantly higher than the others, while the conventional catalyst being the lowest. It is also interesting to note that the catalyst lifetime, while evaluating the feasibility of the catalyst. According to literature, the conventional catalyst has a lifetime of 5 years. It is fascinating to find out that MOF-based catalysts can sustain 3 times longer, and on the other hand, single-atom catalysts can sustain 4 times longer than the conventional nickel alumina respectively. Therefore, in account of the 20 years project lifespan, the conventional catalyst will need to be replaced 4 times. This contributes to the surge of synthesis cost as compared to the single-atom catalyst that can sustain 20 years. Nevertheless, the cost associated with MOF-based catalyst is approximately triple of the conventional catalyst due to its very high material cost in synthesizing them. Moving on to environmental analysis, it can be analyzed on the carbon emission from the synthesis of the catalyst. From here, carbon emission from the single-atom catalyst, nickel HAP, is actually the highest, as compared to the conventional and MOF-based catalysts. However, in account of a 20 years project lifespan, the carbon footprint observed from nickel alumina catalyst is about double of the noble catalyst. This further validates the potential of the proposed noble catalyst in carbon dioxide mitigation. By considering both economic and environmental performance, nickel HFC catalyst is found to be the most feasible nickel-based catalyst due to its competitive cost and environmental benefits. In addition, nickel MIL53 catalyst also possess an undeniable potential in use as compared to the conventional catalyst. This project has provided a useful insight of possible upscaling of noble catalyst production. Furthermore, noble catalyst has proven its capability to replace the conventional catalyst due to its economic feasibility. Noble catalysts are also proven to be more environmental friendly than the conventional catalyst. So, you may have doubt on the upscaling capability. To that, there are plenty of research articles have showcased the possibility of upscaling the proposed noble catalyst. Nevertheless, these are limited to kilogram cells at the moment. Therefore, a 3D printed catalyst can provide an unbelievable golden opportunity for larger scale production. This is because a 3D printer can sensitively control the desired morphology and characterization of the catalyst, which is essential in producing both MOF-based and single-atom catalysts. In addition, it consumes lower energy consumption, more cost-effective, and safer operation. In actual fact, there is an increasing trend which proves the capability of producing 3D printed catalysts in recent years. Indeed, this provides a shining future of mass production for both MOF-based and single-atom catalysts and their application in dry methane reforming. This brings to an end to our pitching presentation. We sincerely appreciate your attention, and should you have doubts or collaboration opportunities, please feel free to contact us. Thank you.
All right. So Team SG20A020, can you emphasizely relate your project to our theme of this SEA-GIC 2020, which is battling climate change through chemistry? Can you emphasizely relate your project to our theme?
Sure. Because we utilize the carbon dioxide that actually released to the environment that can impact the environment to use as a feedstock to produce hydrogen. So we actually valorize the emission gas to generate wealth, which is hydrogen gas, which is very important in this era.
Understood. I can see the rising of researchers in both developing and focusing on the hydrogen technology. It is much greener and cleaner technology, to be precise, and it is definitely a way to combat climate change in terms of reducing the carbon dioxide emission. All right. So I think I shall call group SG20A027 to start your presentation. You can start to request control, and you may start your presentation.
Okay, ladies and gentlemen, and educator from the South Asia Global Innovation Challenge, we are from Brawijaya University is present. Ladies and gentlemen, as the electrical energy is very needed in society in the world, is especially in Indonesia. In Indonesia, is electrical energy is availability in the world. The energy is demand in Indonesia is always increased from years to years. Ladies and gentlemen, and educator, as we know that in Indonesia as world consumed more than 3,000 kilowatt electrical energy. In 2015, Indonesia has consumed 5,117,000 kilowatt electrical energy. Like the earlier results from the CRISI in 2012 explain about the electrical energy production from the microbial fuel cell and the tempe industrial waste as the confront from the electrical energy. But the result is the low voltage is not effective to implementation in Indonesia. And the number two is Ibrahim et al. Ibrahim et al. Is how to convert the microbial fuel cell on the first industry waste to produce electrical energy. This Ibrahim is research ineffective to implementation in our society because this is low voltage in Indonesia. So this problem, we give the solution from Brawijaya University. My name is Muhammad Sarifuddin. I'm my partner in Muhammad Kadifi Kasim in Alivia Sinta and the mentor of the Professor Amis Tiolaksono PhD. We give the innovation about Excel. What is XLO, ladies and gentlemen? XLO is utilization, how to of human waste to make the new and renewable electrical energy based on mobile application and isolated village to achieve SDGs point 7 2030. Ladies and gentlemen, an educator, what is XLO? Explore in here the technology to convert the human waste to electrical energy. The electrical energy is efficient to consume the human, especially in Indonesia, as well near the electrical energy. So we believe Exlo is very benefit from the society. We have the material and the tools to make the technology Exlo. The number one is tools. We get the dual chamber, boost converter, transistor, and then transfer step up to increase the voltage from technology Exlo. And then the materials, we need the human waste and the E. coli bacteria and the nutrient board and aqueous. Ladies and gentlemen, an educator, we have the three device planning to make the technology Exlo. Number one, MFC, microbial fuel cell. It technology to generate bacteria in the society to electrical energy. And number two, we need the boost converter. And the number three, DC to AC inverting to convert DC to AC voltage. Ladies and gentlemen, an educator, what is the device manufacturing stage? Number one, we get the literature study. In literature study, this earlier research analysis about the theory, microbial fuel cell, application mobile, human waste, and extra. And number two, we get the program need analyze. In the program need analyze, we is collecting materials and tools needed to make the prototype and ready to use in device. Ladies and gentlemen, and the number three, we do the design prototyping. Design is in three design and then three design form. As the reference to build the prototype technology Exlo. Ladies and gentlemen, an educator and a board of device are planning, we do the device assembly. Device assembly is start with the simple to the complex circuits, the assembly prototype and ready to use device. And number five, we do the evaluation. Okay, ladies and gentlemen, do a vision evaluation. This is tool that the device is ready to be applied in society. So this is our prototype 3D from the technology Exlo. As we know that technology Exlo we make in the laboratory of mathematics and science in Brawijaya University. This is our product prototype. So now our product is ready to implementation in society, especially in Malang, Indonesia. How to generate human waste to electrical energy. So in here, we put the human waste in the chamber. This is a chamber. So if after we input the human waste in the chamber, we send the human waste to the dual chamber. It is dual chamber. This is chamber anode and a chamber cathode. And the chamber anode is the positive ion and the ion, and then cathode is a negative ion. So in the positive ion and negative ion is communication is the map the electrical energy. In here this produce electrical energy, so we save and the boost converter. In here boost converter to save electrical energy. After that we need the DC to AC inverting. But a DC to AC inverting is can consume the electrical from the society. After that we can put electrical energy at the stop contact so the society can use electrical energy from the human waste. Ladies and gentlemen, an educator, this is our video experiment in the laboratorium, Faculty of Mathematics Science in Brawijaya University.
All right, thank you, Team SG20A03.
Okay, ladies and gentlemen,
sorry.
This is our video experiment. This 3 liter from the human waste we can generate from the electrical energy. So the efficiency is 95%. So we believe Human waste is more potential in Indonesia, especially in the world in the general, can convert the electrical energy. Ladies and gentlemen, an adjudicator. This is a device mechanism to turn on the lamp. This is our experiment in my laboratorium. This is we need the salt and then the human waste. This is all human waste, ladies and gentlemen. Human waste we generate to electrical energy. We need in here we can turn on the lamp. Turn on the lamp is every 2 weeks. We can turn on the lamp is 2 weeks. This is our experiment. We need the material like the boost converter and etc. Okay, and then the how to device application. So in here we make the device application. Why we make this? Because it can more the easy use the people. As we know that human waste is very not good the aroma, so we need the application to make the technology excel. Okay, this is the IoT mechanism. In here, this is our IoT mechanism. Number one, the application is the request data from the Firebase. Ladies and gentlemen, Firebase is like the bridge between the technology Excel and then the application Excel. So the application can the request data like the bridge Firebase and request data in the in the technology Excel. Technology Excel it get the microcontroller Arduino Uno. Microcontroller Arduino it can the send data back to the Firebase, and then Firebase send data to the application, and the application it can show about how much substrate in the technology Excel. We can on off automatically. We can know temperature from the technology Excel. Ladies and gentlemen, in our results, in our technology, we get the 4 stakeholders to develop our results. Number one, the Ministry of the Energy and Mineral Resources in Indonesia to promotion our technology excel. Number two, the academies, especially in Brawijaya University in Indonesia. And number three, society in mind people to use technology excel. And number four is community to support society to use technology excel. Ladies and gentlemen and educator, so excel is the device that convert the human waste into electrical energy. This best application mobile and 3 liter of human waste, we can generate 22 volts with this 90 watt of efficient level. And ladies and gentlemen, Axelois can fulfill electrical energy needs in the isolate village and then in support international program on SDGs Point 7 2030. Ladies and gentlemen, so try not to become a man of success rather than becoming a man of value. Thank you for your attention, and we can beg a moderator. Wassalamualaikum warahmatullahi wabarakatuh. This is our patent letter from Brawijaya University.
Despite the mature status of conventional carbon and sequestration technology that utilize chemical absorption of carbon dioxide by using acanolamine have been proven to suffer from the acanolamine toxicity and corrosive properties that can cause irreversible damage to nature. Combined with the high regeneration enthalpy of the acanolamine itself, that require massive energy input, this issue has become a major dilemma that require swift action from researchers all around the globe. By adhering to the several fundamentals of 12 green principles, our group from the University Technology Petronas opted for dry lab research by conducting molecular dynamic simulations discover a breakthrough in developing state-of-the-art carbon capture technology of choline alanine zeolitic emergent ZIF-8 framework composites. Ladies and gentlemen, next slide.
Me, organizer, I don't have a request. Can you approve my request?
Can you request control one more time?
We have conducted a molecular dynamics simulation to determine the free solvation energy of carbon dioxide inside choline alanine zeolitic imidazolate framework A composites of different weight ratio at various simulation temperature and pressure. Then, the information from the free solvation energy simulation was used to calculate the solubility and absorption enthalpy of carbon dioxide inside the choline alanine ZIF8 composites.
Ladies and gentlemen, the culmination of this project was possible due to the prior molecular dynamics simulation research paper that was published in the Journal of Hazardous Material that studies the carbon dioxide and hydrogen sulfide adsorption properties inside choline-based ionic liquids and isoreticular metal organic framework composites. Inspired by that works, the development for these novel composites was executed by impregnating extremely hydrophobic and thermochemically stable zeolitic imidazolate framework 8 pores with choline alanine, a benign and biodegradable choline-based amino acid ionic liquid that can be synthesized from renewable sources. Impregnation of choline alanine inside the zeolitic imidazolate framework 8 modified the nanocageous environment of the pores, leading to the augmented adsorption of carbon dioxide. Apart from the pore modification executed by the impregnation of choline alanine, the hydrophobic properties of zeolitic imidazolate framework 8 is another crucial property that ensure no interference from the incoming water vapor during the carbon dioxide adsorption process and jeopardize the integrity of the composites that may lead to the reduce in adsorption capacity of the composites. 3 different weight ratio of choline alanine ZIF8 composites were used in this project. Free solvation energy of carbon dioxide simulation inside each composite was carried out at 2 different temperatures and 5 different pressures. In the span of 2 months, involving 30 different simulation systems, we discovered that 0.8 choline alanine ZIF8 composite at 298.15 Kelvin and 10 bar display the highest carbon dioxide solubility at 0.079 mole per liter bar, with the extremely low adsorption enthalpy of negative 1.68 kilojoule per mole. These simulation results gave a glimpse of hope for the development of carbon capture and sequestration technology that has high performance with minimal energy penalty for the regeneration of the composites. Esteemed judges and fellow audiences, the time is ticking, and after 5 years since United Nations set the Sustainable Development Goals to motion, we have yet to come to a sustainable solution that can reduce carbon dioxide emission as well as mitigating the climate change impacts. Nevertheless, by resorting to molecular dynamic simulation, which is a component of the dry lab, both research time and research costs can be reduced substantially. Furthermore, through molecular dynamic simulation, our work has shown that mild reaction condition in capturing carbon dioxide can be achieved by using newly developed choline alanine ZIF8 composites. With this state-of-the-art choline alanine ZIF8 composites, sustainable carbon capture and sequestration technology that boasts efficient energy usage can be achieved within the next few years as we push forward in our endeavor of making this world a better place for future generations. We would like to extend our gratitude to Fundamental Research Grant Scheme and Yayasan University Technology Petronas for the financial support throughout our research. And we are honored to have any collaboration offers that can further enhance the fundamental research conducted in this project. That's all from me and my colleague. Thank you very much.
All right, thank you, Team SG20A045, for your presentation. We should welcome the next team, Team SG20A014 from University Malaya to pitch their project.
Greetings, this is me, Sharmali, and my partner Nick. We are from the University of Malaya, and today we are bringing out our idea on the plastic bin. So we made plastic, and now we are drowning it. The miracle material has made modern life possible. However, the victim of this success appears to be life on Earth. We are addicted to plastic. But how did the world become so dependent on it in the first place? It is present in almost every aspect of modern life, from water bottles to aircraft. They were so cheap, we began to make things we never intended to keep. Decades later, more than 400 million tons of plastic produced each year is discarded within minutes after purchase. Humanity's relationship with plastic is rather schizophrenic. We see it on our streets, rivers and lakes, on our beaches, and even in our deepest ocean. Part of the problem is that people are at times still unaware of the scale of the problem, the full extent of the devastating damage being done to our planet by our petty, neglectful action. The idea of development and economy has moved us far from this reality. It's time for us to make a more mature decision. So, what could be another of mankind's latest revolution in the fight against plastic? Our answer today would be the plastic bin.
Next.
I'm already on the next page.
Okay. In 2016, scientists has found an interesting bacterium called Ionella sequences that can digest plastic, specifically polyethylene terephthalate or PET. The bacterium was found to be able to do this because it has a specific type of enzyme dubbed PETase for its ability to break down PET into MHET and finally into terephthalic acid and ethylene glycol via hydrolysis. Next. The enzyme produced by the Ionella sequences is at very low concentration and it is in fact the time for the reaction to occur and the enzyme is hardly to be found. The synthetic PETase is synthesized to mimic the degradation of plastic. To achieve that, PETase is synthesized in the lab via chemical ligation where all the fragments of small amino acids are assembled to become huge structures of the enzyme. And the screen shows the structure of the PETase. As I can recall, the structure is built up by the small fragments of the amino acid to become like this. Next. However, as we notice, this enzyme is thermally unstable. The instability of the enzyme is caused by the lack of the hydrogen bond inside the major site of the core, since this enzyme belongs to alpha-beta hydrolase superfamily. Next. Hence, protein engineering knowledge is applied to this enzyme to mutate the structure. To mutate this enzyme, histidine and aspartic acids are introduced to ensure that the hydrogen bomb is formed, hence the structure is strengthened. Next. The bacterium, however, has several disadvantages that make it unsuitable for use. They produce endotoxin, require a rich carbon source to grow, and their overly rapid growth present a threat when leaked into the environment. Therefore, we engineer a type of microalgae, Chlamydomonas rinhardtii, to express the PETase enzyme. This microalgae is much more environmental friendly solution and is generally recognized as safe. The microalgae does not require organic carbon sources under phototrophic condition, nor does it produce endotoxin.
So, since this idea, platform, we came up with plastic bin. We use our microalgae in a microbiofuel cell to further treat the PET degradation and produce a small amount of electricity. To picture, the plastic bin is a simple setup that consists of two chambers. In the top chamber, the PET waste is shredded into small chips and put together with our PETase balls. The bin is then covered and the reaction are allowed to proceed on its own. In our system, a layer of agar culture which contains the alga Chlamydomonas rinhardtii that holds the PETase enzyme is grown on a surface of polymer balls. The agar is covered with a layer of alginate to protect it from any possible scratch damage. These polymer balls are brought in contact with the PETase waste in the chamber at the top. Principally, the plastic bin takes advantage of three reactions, the first being the use of PETase enzyme to catalyze the degradation of PET. In this step, the PETase balls are brought in close contact with the PET plastic chip and they can react to give terephthalic acid and ethylene glycol. And because both the products are denser than water, they would sink through the wire mesh into the fuel cell below. The next set of reaction happens in the lower chamber of the cell. In the microbiofuel cell, carbon plates are arranged alternatively and they work as a working and counter electron. They are arranged alternatively close to each other to reduce any solution resistance. The reaction here uses the bacterium Deflacerohanthensis to metabolize terephthalic acid into carbon dioxide, water, and small amount of unmetabolized byproduct. Similarly, a third reaction uses a mixed consortium of anaerobic bacteria to break down ethylene glycol into mainly carbon dioxide and water again, and again a small amount of less but harmful byproduct. The working electrodes, the anodes, are coated with a layer of conducting polymer P2PSS that contains either the Deflacerohanthensis or the mixed consortium of anaerobic bacteria. A layer of alginate is again used to protect the agar layer. Both the processes here, Deflacerohanthensis and a mixed bacteria metabolize the terephthalic acid and ethylene glycol, using them as a carbon source for growth. Part of the energy generated in this process is stolen by the carbon collector as free electrons. Both the processes produce electrons which flow through the carbon collector and then the cathode to produce electricity, which is used to power an indicator light. The electricity here is used as a signal to monitor the health of our system. A drainage valve is positioned at one side to remove spent water electrolyte once the reaction is completed. It is outfitted with successively smaller sieves to catch any possible unreacted PET microplastic so that they do not contaminate our environment again. The spent water electrolyte will be filtered through a simple sand filter before disposal. This modest concept and setup can break down PET completely and sustainably while being easy to operate and does not require constant supervision. It has relatively simple construction which will ease any maintenance work, and the added advantage of being self-sufficient, they do not need energy input. So it can be envisioned that this system are widely installed in residential homes and areas and schools where responsible citizens can play their part by safely disposing PET waste in them. Our system can serve as a complementary effect to reduce plastic waste and keep them out of our nature, slowly but surely. Thank you.
All right, thank you, Team SG20A014 for your presentation. So I think we shall now welcome the next team.
Thank you.
Team SG, all right, thank you. All right, Team SG20A052 from Universitas Asia Yogyakarta to start your presentation. Please welcome.
We are the first generation to feel the effect of climate change and the last generation who can do something about it. Barack Obama. Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. Today, we want to present our idea to combat climate change, which is artificial tropical algae forest, a smart solution to combat climate change. First, let me introduce our team. I am Panji Agung Nugroho as the leader, and then Syarifah Tiara Nurintan, Gradia Martin Jati Pramareti, and Miss Anissa Humairah as our advisor. We are a biotechnological student of UNISA, and we are from Indonesia. Next.
Higher levels of CO2 in the air cause the Earth's surface temperature to increase, resulting in global climate change. If you don't take any countermeasure, the climate change that will happen will get worse. Next. The sea has great potential to overcome this problem, one of which is the algae forest. Coal forest has great potential because it has a good ability to absorb CO2. However, coal forests can only grow in cold water areas to not survive in tropical climatic conditions. Next. The opportunities for developing tropical marine algae forests are huge because equatorial regions such as Southeast Asia receive sunlight all year round. Therefore, we want to use the same mechanism in tropical areas using algae from the species Sargassum sp, which can grow on the coast of tropical seas. In addition, Sargassum sp has advantages such as a high growth rate and is more resistant to rising seawater temperatures. Sargassum SP can produce high biomass and contribute to climate change mitigation to a high carbon storage level of 30.2x2%. With the right system, artificial tropical algae forests can contribute significantly to reducing CO2 levels in the future. Next.
Next is about the purposes. The main purposes of our project, which is artificial tropical algae forest, is to absorb CO2 from the air naturally with a simple and cheap system, which can also then be used for other purposes. Next. Next is about the material. The materials is that need to make the artificial algae forest are erupt, football, wake stone, and seedlings of Sargassum sp. Next. Now we're gonna talking about a method. There are 4 steps we do in our method to produce artificial algae, which is first material preparation, second making a first framework, third forest placement, and fourth as the last method is routine maintenance. Next. Now as what I mentioned before, the first step is material preparation. The use P-erupt uses a rock with a diameter of 8 to 10 mm so that the forest structure is strong. The stone weight used can be made of natural rock or made using cement by a local community. The algae seeds come from the cod algae of Sargassum sp. Next. Next, as second step, is about making a forest framework. The first framework is made with ropes and area 10 by 10 meters and height of meters of 5 to 10 meters depending on water conditions. The distance between the vertical ropes is 50 to 70 centimeters to maximize the light and water flow for algae growth. The frame is then installed with a ballast weight and float ball to form a vertical structure. Mature algae seeds that have been caught are implemented in the forest skeleton. Next. Then is the third step, which is forest placement. The finished forest is taken by boat and then placed in the selected area. The algae forest area must be in the area without coral reefs so as not to damage the natural ecosystem. And area was also selected where the ships did not pass through. The area is also expected to have a fairly calm current. Next. No, we talking about 4 steps, which is the last step in our method is about routine maintenance. Algae forests require regular monitoring and maintenance, such as cutting down overgrown algae and then can be used as raw material in the food, pharmaceutical, cosmetics, feeds, fertilizer, textile, paper, and so on industry. Thank you. Next.
Photosynthesis is the main mechanism of this forest algae in reducing CO2 level. Algae cell will absorb CO2, water molecules, and sunlight to produce glucose and oxygen. And then the glucose molecule is converted into another form of carbohydrate, in this case, alginate. In fact, Sargassum sp is one of the algae that has a high carbon storage level. In 2015 research showed that Sargassum sp can absorb CO2 as much as 2,202 tons per square kilometer. Based on the data, if we cover only 1% sea area in Southeast Asia, we can remove about 11 million tons of CO2. With the system that we create, this algae forest is expected to maximize the absorption of CO2 from the air. Artificial tropical algae forests are a smart solution to tackling climate change because the system has several advantages. First, it's minimal maintenance. This system uses live biological agent in the form of microalgae, and human's role is only when planting, placement, routine care, and algae will naturally absorb CO2 by photosynthesis. Next, it's cheap and simple. With an estimated cost of around 4 to 5 million rupiah or 200 to 300 US dollar per forest unit, it is considered cheap because forests can function for a long time as long as the forest structure is still functioning properly. The only needed tools, like we mentioned before, are PE ropes, float balls, weight stone, and algae seedling. The weight stone can use natural stone or be made independently by the local community, and the algae seedling can use excess algae from previously grown algae forest. Next, its multifunctional system. Apart from its main function as a CO2 absorber, artificial algae forest can also be used as an artificial ecosystem to restore the wealth of marine ecosystem that were previously damaged. The algae forest can function as a shelter for small marine animals. Algae forests can also remove pollutants such as excess fertilizer from the water. Algae forests can also be used for economic activities such as oyster and fish cultivation with certain limitation. With strict regulation, the local community can use excess algae such for various activities, and the algae forest can use for tourist attraction. Next, it's creating new jobs. The system is simple to talk easily to general public in coastal area to run this program together. Local people can be employed as forest supervisor in their area. In addition, planting and making forest frames must be done manually so that local people can be employed, so the algae forest will give direct or indirect positive impact to the local area. Next, it's future development. The development of this algae forest can be done by genetic modification of the algae to grow faster and more resistant to temperature increase. It is also possible to develop another form of algae forest so that it can be more efficient. And it is also possible to use another type of algae that's suitable in certain area. And this is the video of our prototype, which is there is a float balls, weight stone, PE rope, and the algae. And the algae forest in this prototype is floating on the water. And the last from us, let's make a simple thing do a great thing. Thank you.
Alright, thank you, Team SG20A052. Alright, now I think I shall welcome your Team SG20A015 from University Science Malaysia to pitch their project. Please welcome.
A very warm afternoon to the respected judges and to everyone present today. We are representing University Science Malaysia Engineering Campus, code SG20A015. The group members are Divya Paramasivam, myself Satish Kumar Manogaran, and Logania Subramaniam. We are currently in our third year of Bachelor of Chemical Engineering. Our group advisor is Ayah Dr. ING Nur Ashrina Abdul Hamid. Today we would like to pitch further about our project titled EBIN, A Way to Battle Climate Change. The problem statement of our project is the plastic waste that have been increasing drastically in our environment. You may ask us why this happens. If we think logically, plastic has many advantages in terms of its usage. Some of those advantages that make plastic to be used most by us is first, it is light in weight, second, it is cheap, and third, it is long-lasting. Please note the word long-lasting. Plastic also considered as a main contributor to climate change. This is because plastic is naturally very hard to decompose. Sunlight and heat cause the plastic to release such powerful greenhouse gases such as ethylene and methane. The increasing concentration of these gases in this atmosphere leads to an alarming feedback, which is climate change. If you observe the graphs in this slide carefully, it is known that plastic production has been increasing rapidly from the year 1950 to year 2015 and tops the chart in the year 2015. By that year, plastic has literally outgrown most man-made materials in this environment. It is also clear, on the other hand, that the plastic waste are either discarded into the environment just like that, which eventually ends up in rivers and oceans, or incinerated where toxic and greenhouse gases are released to the atmosphere. The rate of these plastic waste that are being recycled is very less, in fact, which is almost 20%. This generally explains our purpose to begin this project in the first place. While in this chart, it is so clear that Asia holds the first place in discharging plastic waste into rivers and oceans, which is something not to be proud of even a little. And you're probably wondering what disposing plastic waste into oceans and rivers could do. When the microplastics present in the ocean and rivers are unwittingly ingested by the plankton populations, it may threaten them. This causes more carbon to re-enter the waters and atmosphere, leaving a greater impact behind. The aims of our project are to battle climate change, to combat this ever-increasing dumping of plastic waste, to ease the work of collecting and recycling plastic waste, and finally to convert the plastics into biofuel that we use in our daily lives. Now, I would like to pass it to the next presenter.
Thank you, Satish. And I would like to continue my discussion with project activities. And there is two project activity. One is E-beam and another one is cold plasma pyrolysis. And now I'm going to explain about E-beam. Next slide. The function of the E-beam is to reduce plastic waste and to avoid climate change. The material that we would like to use to make the E-beam is compost wood, and it will be coated with black color so that maximum amount of light energy can be absorbed by the E-beam. The dimension of the E-beam is 120 by 100 by 150 centimeter. The components that involve in the E-beam are solar panel system, infrared sensor, proximity sensor, weight sensor, and lastly piston. The solar panel system is used to absorb light energy and convert it into electric current, while infrared sensor will detect the amount of incoming plastic and send information to the microcontrollers. Proximity sensor will be placed at the bottom of the E-beam so that it can vacuum plastic near to it. Weight sensors will be placed at all the 4 chambers to calculate the total percentage of plastic present in the E-beam. Lastly, piston involved in the E-beam so that it can compress the plastic in the chamber to increase the space inside it. Next slide. Basically, this is our design of our E-beam and it consists of touchscreen. This touchscreen will help humans to choose which type of plastic that they're going to put inside the E-beam, whether it is high density polyethylene, low density polyethylene or polypropylene. This E-beam consists of totally 4 chambers. The first chamber is HDPE followed by LDPE, third chamber is PP and the last chamber is specially for vacuum. The length of the E-beam is 120 cm followed by width 100 cm and the height is 150 cm. Next slide. Basically, this is the cross-section view of our E-beam from the front view. Next slide. This is the process flow of our project. First of all, human must choose which type of plastic that they're going to put inside the E-beam, and then the plastic will be sent to the chamber according to the type of plastic. E-beam will sanitize automatically after an individual passed from the place to prevent the spreading of coronavirus. When the plastic reaches the maximum capacity in the E-beam, the assigned management will be known through phone as the E-beam is programmed and connected through an app, and that particular app is owned by Pyrolysis Center crews. Then the Pyrolysis Center crews will reach the E-beam and collect the plastic from the E-beam. And the plastics will be sent to the Pyrolysis Center, and lastly, it will be converted into fuel. That's all from me, and I would like to pass it to Logania.
Thank you, Divya. So first of all, pyrolysis is a process of thermal decomposition of organic materials at high temperature with limited amount of oxygen. So adding cold plasma into this process will break down the chemical bonds to initiate and excite reactions, allowing for the extraction of these materials before they are burnt. Cold plasma will also decrease the reaction time. Next. So as we see the alterations on the design, first of all, stainless steel outside wall of combustion chamber. This is so that the chamber lasts long. And then asbestos for inside wall and glass wool for the middle wall. This is to maintain the even heat transfer. And then vertical cylinders are used so that the handling will be easy and it is affordable. And various adjustment options and controlled operation are available. Then, pressure monitoring device is installed to control the pressure in the reactor, as well as thermocouple is also installed to always monitor the temperature of the reaction, as temperature plays a major role in this reaction. Zeolite Active Plus is used for product purification, iron filter to trap the evaporated oil. Nitrogen gas is used to clean the reactor before starting. Lastly, calcium carbonate as adsorbent is used for better production of oil yield and to shorten the reaction time. Next. For better and specific reaction, first of all, the properties of pyrolysis oil can be improved by hydrogenation. Then, preheat the reactor before starting. Catalytic reaction, where we use silica alumina as the most common catalyst is used to produce gaseous fuels, whereas thermal reaction is used to produce liquid fuels. Lastly, we can also add used lubricant oil to produce diesel-like fuel. Next. As we see the process flow of the pyrolysis process, first of all, waste plastics from the plastic snapper will enter the pyrolysis reactor where catalyst will be added according to its reaction, and then the product will go to the condenser to produce fuel gas and mixed oil. The mixed oil will then go to fractionating tower to produce gasoline and diesel. Next. I would like to pass to Satish to continue.
Thank you, Lognia, for the brief explanation about pyrolysis process. Now let's look at the outcome from this project, which is converting waste plastics into hydrogen, methane, and ethylene, as well as oils. Both hydrogen and methane can be used as clean oils. The impacts from this project are it reduces plastic waste in our sanitary landfill, it enhances recycling in society, it improves the knowledge of society regarding plastics, it produces eco-friendly environment, it reduces overflowing bins and unpleasant odors, it produces cleaner streets and walkways, and produces more fuels. This project can be scaled up by creating more and more e-bins, as the design of this e-bin is already available in simple and easy form to understand. Consequently, more amount of biofuels and oils can be produced with this number of e-bins available. Our presentation ends here. Thank you for listening.
All right, thank you, Team SG20A015 for your presentation. We should welcome the next team, which is Team SG20A042 from University Technology Malaysia to pitch their project. Please welcome.
Hello to the organizer, judges, and all the participants. We are from SG20A024 from University of Technology Malaysia. I'm Teo Jing.
I'm Amir.
Our topic would be on the reduction of carbon dioxide using Algolite. And from our topic, you might have an idea that our proposed invention is somehow related to light. But how can carbon dioxide reduction be related or be linked to lights? So before my member Amir will reveal the operation, we will leave it for you to guess.
The Southeast Asia is particularly exposed to the impact of the climate change. And according to the Asian Development Bank, the Southeast Asia recorded the fastest growth emission in the world is between 1990 and 2010. Here shows the carbon dioxide emission from each country. And the data show that although these countries cover less than 1% of the Earth's surface, have consumed 75% of the world's energy and caused the 75% of the global greenhouse gas emission. However, the climate change is not only urgent in Southeast Asia, but a worldwide issue. And from 1990 to 2015, next slide. Thank you. The total warming effect from the greenhouse gases to the Earth's atmosphere increased by 37%, as we can see from the chart previous slide. The carbon dioxide is primary greenhouse gas and accounting for about 76% to 81% of total greenhouse gas. And the carbon capture and storage, which is the process of capturing the carbon dioxide and depositing it to prevent the emission to the atmosphere, is an attempt to limit the effects of the global climate change. Next slide. As we can see from this chart, the carbon dioxide emission in Malaysia is mainly contributed by the electricity and heat generation. And do you guys know that the street lighting is actually one of the biggest electrical energy consumer, which accounting for up to 40% of the total energy consumption in standard city worldwide. And the lighting accounts for nearly 5% of global carbon dioxide emissions. Malaysia government is spending about 80 million ringgit annually on the power bills and nationwide village street light maintenance.
However, the street lighting is an essential public service and cannot be separated from our life. Therefore, the electricity cost and the environmental factor have inspired our teams for this innovation. Another issue in Southeast Asia regarding the climate change is the harmful algae bloom. The warmer water due to the climate change might favor the harmful algae growth and increase the algae bloom occurrence in the Southeast Asia. And in this case, Philippines and Malaysia are two of the most affected countries. And this is an unhealthy cycle in which the climate change causes warm water to boost the algae growth, and this develop to a thicker blooms that absorb more heat and cause the water warmer that enhance the blooms. Therefore, we are cultivating the microalgae as a part of our project, which can reduce the algae blooms besides combat the climate change. And the biomass produced can be collected and used as the aqua feed and animal feed. Besides reducing the algae blooms and climate change, we are using the microalgae because of its promising future as a renewable energy, the potential application in biopharmaceutical and nutraceutical industry, as well as the wastewater treatment. And as a brief for our project, we are using the carbon dioxide, the solar energy, and wastewater for the algae cultivation, implemented with the street lighting as well. And our objective is to achieve the climate protection and the wastewater treatment at the same time.
So to counter all the problems, an innovative streetlight as the substitution of the usual streetlight has been proposed, and we name it as Algolite. As our main concern is reducing carbon dioxide concentration in the ambient air, the microalgae are able to convert the carbon dioxide into useful biomass and oxygen. The efficiency of algae in capturing carbon has proven to be 400 times more effective than trees taking the same footprint. Next. What makes this Algolite as the promising future is because of the thru mode system. The thru mode system is not only cover one aspect, but it covers three remarkable aspects. The first one is the hybrid system of microalgae and solar-powered streetlight. This means that it acts as a carbon dioxide converter and illuminates the surrounding area without the utilization of electricity. Next, this innovation can function both day and night. Microalgae utilize sunlight to convert carbon dioxide into biomass and oxygen, making the conventional reactor not operate at night. With the integration of LED that is brighter and more energy efficient, microalgae are able to convert the carbon dioxide in the air by utilizing the bright artificial light even at night. And the last aspect is the algolite able to treat wastewater or oxidation ponds that are rich in nitrogen and phosphorus. The treated water can be released back to the river. Next. There are three main aspects in conducting this project. The first one is the integration of solar panel and battery storage to the Algolite. The second one is designing and development of algae photobioreactor, also optimizing the growth of the microalgae. And the last one is the production of bio-based product from microalgae biomass, such as for animal feed. So in order to realize this Algolite, we have tested the required aspect in a small or laboratory scale. The results have proven that the microalgae are able to reduce the concentration of carbon dioxide, even supplemented with LED as the source of light. Moreover, this Algolite is not just a random idea. Under the supervision of our advisor, our senior has developed artificial tree using the same concept and won IBCX in 2019. However, our generation does not stop here. We take this idea even further through Algolite. Artificial tree aim at reducing carbon dioxide indoor, but with Algolite, it can be applied both indoor and outdoor. This can be achieved with Algolite because of higher capacity on absorbing carbon dioxide, zero electricity usage, and thru mode system that allow the reactor to function all day long. This is the process of cultivation of microalgae that will be used for our Algolite. Besides, the efficiency of using solar panel on pumping and aeration has been tested on a smaller scale. The result is amazing and ready to be applied on a larger scale, which is Algolite. We have tested on cultivating the microalgae using water from the oxidation pond located near our faculty. Based on our study, microalgae are able to treat the water by reducing the organic content in it. The water then is safe to be released into the river. This is truly impressive as it extends the capability to save our planet by not only reducing the carbon dioxide in the air, but also treating the contaminated water surrounding us. We really hope that this innovation will be as successful as artificial tree. This may help us in reducing carbon dioxide both indoor and outdoors.
So for a quick recap, as well as been mentioned by my team members, the significance or the values brought by our proposed invention is that the currently available main culprit for global warming, which is carbon dioxide, is reduced through utilization by these microalgae, and it further prevents the production of more carbon dioxide when it's used as substitution for normal street light in the generation of energy. So why should we choose Algolite? We know very well that deforestation and the dependence on fossil fuels can only be cut down but not eliminated, because let's be practical, the development of the country and also the accommodation of to increase the for the increasing population definitely requires some unavoidable sacrifices. And since these sacrifices cannot be avoided, our invention does its best by providing a balance in it by mitigating the negative impacts brought by these developments. So speaking of the financial concerns of our project, just as similar to any other invention, the development stages are always the costliest, but trust me, the invention is truly worthwhile in the long run. So in future, this invention might also be used for electric generation in rural areas as power supply to the underprivileged members of the society. And only inventions that benefits all levels of society can be regarded as good invention. Thank you.
All right, thank
So
you,
that's all.
team SG20 A042 for your presentation. Let's proceed to the third pitching session for today, and let's welcome team SG20 A050 from University of North Sumatra to deliver about their project. Please welcome. All right.
Environment is no one's property to destroy. It's everyone's responsibility to protect. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, our honorable judges and the finalists of SEA-GIC 2020. Today, ladies and gentlemen, we are going to present our project. As we know that human activities are related to electrical energy. The demand for electrical energy in Indonesia continues to grow in line with economic growth and population, and thus uses coal as fuel for very large power plants. At least 27% of the world's total energy output and more than 89% of all electricity is generated from coal due to its overwhelming in quantity, easy and inexpensive extraction process, and low-cost infrastructure requirements. Coal can increase the emission of carbon dioxide particles, which have a negative impact on the environment called global warming. And this is in line with climate change, which encompasses not only rising average temperatures, but also extreme weather events, shifting wildlife population and habitats, rising seas, and a range of other impacts.
Ladies and gentlemen, based on Union of Corset Scientists, Indonesia is one of the 20 carbon dioxide emitting countries in 2018. It is at the rank 9th with the number of emission 0.65 metric gigaton and 10th of per capita emission with 2.30 metric ton. In 2018, total coal consumption in power plant last year reached 18.3 million tons, or 86% of total domestic coal consumption. Ladies and gentlemen, Indonesia is known as a maritime country with an area of 3.22 million kilometers of ocean. So the judges see a river wave energy as an alternative energy generated to the effect of air pressure movement due to fluctuation in wave movement. Ladies and gentlemen, we are Winners Team. I am Lina Sadisregar and my partner is Yasara Ulfa and Hafida Octaviani from University of North Sumatra, Indonesia. Have an idea to solve problem with the title Wave Planner, Water, wave plane modifier based on piezoelectric in supporting the renewable energy.
Wave planner is the right Wave planner is the right technology to solve global warming due to the use of coal to generate electricity by utilizing wave of water. Wave planner is an innovation in electrical energy based on piezoelectric, and it utilizes renewable energy in the form of water waves as the main source of its energy. Next, wave planner. In principle, the wave of the rifle water will hit the buoy at the bottom of the tube. If the buoy moves, it will move the iron handle which is connected to the buoy. Wave planner utilize rifle wave with the help of piezo materials. Piezoelectric is a material that can generate an electric field when applied pressure vibration. Next, the judges wave planner will work out if the water wave hits the floor. This movement can cause magnetic friction. Next, the result at the knobs of connected piezo lying under the magnet on the wooden part. The judges movement from piezo sent to the piezoelectric energy conversion medium, so that it will produce energy in the form of direct electric current or AC. And then the electric current must change into alternating current or DC using rectifier circuit. And finally, it is the stream through a cable connected to the lamp. Ladies and gentlemen, based on the result of the experiment, the electric voltage generated by the wave planner is 12 volts with power 3002.5 watts. Thus, the voltage generated is able to make the lamp turn on.
Sorry. Ladies and gentlemen, what's the advantages from wave planner? The first, the tools used in technology use materials that are cheap and sustainable. And the second, optimization of river water wave, which are natural potential. And the third, environmentally friendly, so it doesn't cause noise pollution, emission, or air pollution. And the last, wave planner is portable technology. Next. And benefit from wave planner. The first is reducing CO emissions that have an impact on the environment. And the second, increase public knowledge related to natural potential such as river, waves, and electricity generator. And the third, information materials and formulation in providing electric energy from natural potential in order to minimize the import burden.
The next slide is implementation and future prospects. The first step we are going to do this technology is technology making. In making this technology, we collaborate with the professionals. The second, we are going to testing the technology. After that, we are establish collaboration with PPPLN and cooperation with regional hubs. By cooperating with PPPLN and the government will make it easier for us to socialize to the community. The next step, we are going to socialization with the community. In socializing the community, we will be helped by communities or organizations, activities, environment. After that, we are going to implementing this technology to our daily life. The last step is evaluation and monitoring to make an update later. Ladies and gentlemen, as you can see here, this is our project display titled SolidWorks software. So, based on our explanation, we get the conclusion that post-plenum technology is an appropriate technology in providing electrical energy by utilizing rudder waves. The resulting voltage is 12 volts DC with a power of 302.5 watts. Work-planar technology is also a renewable energy is an alternative solution to overcome global warming in 13 years. Uh, that is our explanation about our project. Thank you for your attention. Don't forget to love our environment and save our planet. Wassalamualaikum warahmatullahi wabarakatuh.
All right, thank you, Group SG20A050 for your presentation. We should welcome the next team, Team SG20A008 from University Kebangsaan Malaysia to start pitching on their project. Please welcome.
Carbon dioxide. Who would have thought that this colorless, odorless, and related non-toxic gas would be a threat to humanity in the 21st century? According to the Intergovernmental Panel on Climate Change report, IPCC, at the current rate of CO2 emission, temperature could increase by 2 degrees Celsius that would be detrimental to our Mother Nature. Ever since, most innovation had always focused on solving the issue by reducing CO2 emission, but never using it. What if I tell you if we could use CO2 to build your houses? Assalamu alaikum and a very good afternoon, I bid to the honorable judges and enthusiastic audience. We, from University Kebangsaan Malaysia, are pleased to present you on our title, Capturing CO2 Gas Using Activated Carbon with the theme of Utilization of CO2 Emission in Concrete.
So, how far do we know about cement? Apart of being the second most consumed product in the world, it accounts for 8% of global greenhouse emission every year. Southeast Asia itself contributes to 1.25% of CO2 emission every year. This is equivalent to 871,200 square feet of trees absorbing CO2 every year. Calcination is the process that emits CO2 gas in cement kiln. Heating up limestone thermally decomposes it, and both the process emits a lot of CO2. With that being said, we had clearly identified our problem statement where to minimize the negative impact of climate change by utilizing 1,395 megatons of CO2 emission in Southeast Asia countries by 2030. This makes our problem statement significant, relevant, and measurable. We proved this by showing in graph 1.1 and 1.2 where Southeast Asia is subjected to 1,395 megatons of CO2 emission by 2030. Change is only possible if we align our problem statement based on Sustainable Development Goals. Why SDG goals? Because our objective aligns with 4 SDG goals, which is SDG 3, 8, 12, and 13. Our objective to solve one target out of each SDG goals, which makes our project more relevant and significant to C countries. Our objectives are to chemically manufacture green products that utilize CO2 gas to create a carbon neutral environment by 2030 and to prioritize energy efficient process in manufacturing green products that prevents worsening of climate change by 2030. It might be in Canada, European Union, South Korea, and US, but is there such technology in Southeast Asia? The technology is CCU. CCU stands for Carbon Capture Utilization Technology, where it prevents CO2 emission to the atmosphere by utilizing it. It is a cutting-edge technology that battles for climate change to reduce greenhouse gases. CCU technology has 3 steps: capture, conversion, and utilization. In our case, our project Carbon Result can capture CO2 gas from cement kiln in factories, which is convert CO2 minerals and utilize it as building materials.
Agriculture waste has always been a problem where disposal results in air pollution and landfills. But now we can utilize this waste to synthesize activated carbon. The best part of carbon reserve is where we synthesize AC from agriculture waste tailored to the highest agriculture waste such as EFB, rice husks, and coconut shells in sea countries. The data here shows the agriculture waste where EFB is the highest in Malaysia and Indonesia, where rice husk is the highest for most of sea countries. Interestingly, the Philippines has the highest amount of agriculture waste in rice husks and coconut shells. Now, let's talk about synthesizing AC through pyrolysis techniques from agriculture waste. This technique has three stages where the first stage is carbonization, activation, and the final stage, which is leaching out the ash content. In the first stage of process, biomass is partially burned at constant temperature ranging from 450 to 700 degrees Celsius, approximately to 1 to 2 hours to be converted into biochar. In second stage of process, biochar is then heated in tube furnace with nitrogen gas, which is then adjusted to CO2 gas. Biochar sample takes 1 hour of activation process and it is cooled down under room temperature with presence of nitrogen gas. In final stage process, the sample is refluxed with a potassium carbonate solution and the mixture is filtered and dried. Activated carbon is so promising and superior due to these qualities that we made it as our focal point in our project.
Project Carbon Reserve comprised of 4 important stages in order to produce the end product. Synthesis of carbon reserve starts from absorption, where CO2 gas is released in cement kiln, which is captured and absorbed on the surface of AC through its porous structure. It is worth to mention that the absorption rate is higher through the application of coating on the surface of AC. A specific coating that is made of N-functional group amine is coated on the surface of the AC to absorb CO2 onto the surface. A chemical bonding called dipole-dipole moment is formed between the positively charged N atom and negatively charged C atom. Next, the desorption would allow the absorbed CO2 molecules to be released from the activated carbon mat. The CO2 gas is then channeled into the refrigerator, where it undergoes liquefying process to chemically convert CO2 gas into liquid. Finally, it is redirected into a concrete mixing chamber to be mixed, mineralized, and produce a higher compressive strength concrete. Are you wondering what happens after CO2 liquid mixed with the concrete? Here, we explain about the chemical reaction of carbon reserve concrete. It has 2 main stages to be converted to a solid concrete. Firstly, it undergoes early carbonation, where it produces nanoparticles of calcium carbonate. These nanoparticles are 10 to 80 nanometers in size, which acts as a nucleation site for initial hydration of the cement. The initial hydration stage is where we obtain hydrated calcium silicate, which is the mineral found in the concrete. Note that calcium hydroxide acts as a buffer solution to maintain the high pH alkalinity, which minimizes the possibilities of corrosion in reinforced steel. Also, these nanoparticles result in 30% of higher compressive strength than commercial concrete according to Green Building Index, Malaysia. These graphs proves as evidence that explains how CO2 mixed concrete are stronger and aligns with the standardized strength requirement in construction. Thus, our project outcome brings significant change, and we classified it into 3 major parts. Our green product helps to reduce 1.4 gigatons of CO2 by 2030, manages 1.14 kg of municipal solid waste generated every day, and saves 554 million liters of water that is used in concrete industry every day. Not only that, it is also energy efficient, where microwave has 87% of efficiency, which is the most eco-friendly. More importantly, carbon reserve can bring big impact to an industry of 1.88 trillion in market size, and Southeast Asia can further leverage on $400 billion of CO2 utilization industry in concrete. Project Carbon Reserve also gives you another layer of how this would impact Southeast Asia. Firstly, implementation of policies like incentive-based regulation would encourage more construction companies to build green buildings. This is proved by the future greenhouse scenario graph on the top right, where with current policies, the greenhouse emission would be around 50 to 60 gigatons compared to no policies, which is above 80 gigatons. Our project also boosts the Southeast Asia economy by providing new market and job opportunities as well as GDP growth annually. This can be clearly seen in the graph in the bottom right, where as CO2 emission decreases, the GDP growth increases. From an environment perspective, this project would ensure cleaner air for all, which significantly improves their health. CCU technology would also be adapted quickly in sea countries through this project. Most importantly, carbon reserve provides a carbon-neutral environment where no CO2 would be left escape into the atmosphere without finding its true value. With that, carbon reserve envisioned to provide a cleaner, healthier, better environment for all. Thank you.
All right, thank you, Team SG20A008. Let us welcome next team, Team SG20A019 from Universitas Islam Indonesia to start pitching their project.
Hey, Shahrul, why are you coughing?
Can you see? There is full for smoke in here.
Do something happen there?
Yes, I think in here there's forest fires.
Oh my god, it's very hot today.
Oh my god, are you haven't taken a bath, maybe?
No. I have taken a bath in this morning.
So why?
I don't know, but I think the weather is different than before.
Oh, I see, guys. You like this must be because of the sharp increase of carbon dioxide at this time. Global warming, dirty air, and melting of the ice on both poles of the Earth is caused by the greenhouse effect, which is the result of carbon dioxide production. Okay, guys, I will to tell you about improved carbon dioxide utilization efficiency using seawater by electrochemistry process in closed reactor system. Guys, can you see the picture here? Look, these pictures are different from each other, right? The first picture is in the city in 2009, but the second picture here is the condition of the city at this time. Clearly, we have a big issue with air pollution which contains lots of carbon dioxide. What will happen if we ignore this problem? Guys, do you know? Over the last century, the burning of fossil fuels like coal and oil has increased the concentration atmospheric carbon dioxide. This happens because the coal or oil burning process combines carbon with oxygen in the air make carbon dioxide. Clearing of land, industry, transportation, and other human activities has increased concentration of carbon dioxide. In its fifth assessment report from National Oceanic and Atmospheric Administration, a group of 1,030 independent scientific experts from countries all world cite the industrial activities have raised atmospheric carbon dioxide levels from 190 ppm in 1950 and the level of carbon dioxide increased to 420 ppm in 2020. Carbon dioxide is too high can cause reflex solar thermal radiation, causing an increase in the temperature at the Earth's surface or global warming. Carbon dioxide can cause serious health problems. For example, is acidosis and other respiratory disease. Carbon dioxide needs to be processed into something useful. There are many technologies that are being developed, so that effect of climate change remains below 2 degrees Celsius. Water makes up about 71% of the Earth's surface, while the other 29% consists of continents and islands, consists of 96.5% seawater and 3.5% is freshwater. The major components of seawater contribute to the physical chemical properties of the ocean. Since the major components of seawater are constant throughout the ocean or the market principle, it is possible to treat seawater as an electrolyte solution. Our supervisor is Mr. Wiyogo Priyo Wicaksono with our team are Syahrul Tiara and Mehdi from Islamic University of Indonesia. We have an innovation to build an electrochemical reactor system for the conversion of carbon dioxide to produce hydrogen gas by utilizing seawater as the low-cost electrolyte. Syahrul, do you see Coke anymore?
Yes, I have drink water. I feel so good right now.
Can you help me to explain the mechanism?
Okay, I will tell them about the mechanism. Okay, guys, I will tell you about component of system and mechanism of system. The reactor system, just like a fuel cell, consists of platinum metal as cathode, separator helpless membrane selective, graphite as anode, DC power supply, hose, and hydrogen storage. Hose for carrying carbon dioxide and hydrogen gas to an electrochemical reactor system, DC power for operating system, and hydrogen storage for the stored hydrogen gas. And the reactor is closed reactor system. Okay, this is a video for mechanism of system. Carbon dioxide float in electrolyte solution, in this case seawater, then will dissolve and produce carbonic acid. Carbonic acid will dissolve ion carbonic acid and ion hydrogen gas. In the other hand, in anode, occurs oxidation reaction from water and produce oxygen gas and hydrogen plus. Ion hydrogen plus will go to the cathode, probe helpless membrane selective, and occurs reduction reaction and produce hydrogen gas. Catalysts are contained in water and are connected by a lead wire to cathode. The system is better than photoremediation or chemical treatment. The system can be applied to remove carbon dioxide by inducing polymetric chemical reaction. The system has the advantage of not regenerating carbon dioxide during the process. The system could serve as a novel carbon dioxide utilization technology and high-value added hydrogen gas fuel production device for decreasing climate change. The product in the system is hydrogen gas, and hydrogen gas can be hydrogen fuel for fuel cell vehicle in the future.
Very good explanation, Shahrul. Okay, can you tell them about the advantage of the method?
Hey, Diana, the team is not only you and me. There is Mediana. Mediana, please explain to them about goals and advantages.
Okay. Please be calm, Shahrul. So I will tell them about the goals from this innovation. So the goals from this innovation are: first, optimizing carbon dioxide utilization. The second one, reduce carbon dioxide emission for extreme climate change. And the third one, to create innovative technology for hydrogen gas production as clean fuel. And also the advantage is environmental full friendly. So after we use clean energy, it will not generating carbon dioxide. The second, low cost. It's because the main material is seawater. In the earth consists 68% seawater, so we can get it easily. And the third is user friendly. It causes because our innovation tools is used and simple. And the last is easy to get feedstock, so we can get feedstock it easily. For example, is seawater. And our innovation have an impact and prospect future. The first, reduce carbon dioxide in the atmosphere so the climate change and global warming can be controlled. Second one, provide low cost and innovative technology for industry to managing gas industrial activity waste. And the third, provide hydrogen gas as green fuel energy. So the conclusion is carbon dioxide can be transformed through electrochemically through electrolysis process, then detrimental extreme climate change into renewable, valuable, and inexhaustible hydrogen gas production as a green fuel. So this is the illustrate the carbon dioxide electrochemical reactor that compact, portable, low energy, and user-friendly, so readily for industrial scale-up. And also, the innovation achieved a conversion carbon dioxide to hydrogen gas fuel with high efficiency. So we can battling the climate change by converting carbon dioxide into hydrogen gas through electrochemical. That's all from our presentation. Thank you for your attention. SEA-GIC 2020.
All right, thank you, Team SG20 A019 for your presentation. And now we shall resume to the next team, which is Team SG20 A033 from Swinburne University of Technology Sarawak campus to pitch their project. Please welcome.
Good afternoon to the distinguished panel judges, key speakers, and fellow participants. Today, we're privileged to present our project, CO2 utilization in bicarbonate lime water with industrial waste, for the 2020 Southeast Asia Global Innovation Challenge under the CO2 utilization area. We are chemical engineering students from Simban University of Technology Sarawak campus. First, let me introduce myself. My name is Nur Ali Alisa Azirin, and I will be presenting the problem statement, project aim, and also the project impact. My two other group mates are Emily Tan, where she will be presenting the project activities, and Sylvester Chai, where he will present the project outcome and the ability to scale up. Among the largest anthropogenic sources of CO2 include energy-related CO2 emission at 33 gigatons of CO2 emission in 2019 and cement production, which produces 4.1 gigaton of CO2 in 2018. These two industries combined also produce tremendous industrial solid waste such as cement kiln dust and also fly ash, which amounts to approximately 3.1 billion tons in 2019. The over-emission of CO2 is an inevitable concern that has caused global warming, which leads to climate change. Additionally, even though some of these solid waste has found beneficial application, most of them still needs to be in landfill. Therefore, in this project, we aim to develop an innovative approach to utilize CO2 and the industrial solid waste to produce a construction material, namely the bicarbonate lime mortar with industrial waste, BLMIW, through mineral carbonation process. This project environmental gains include the reduction of greenhouse gas emission and industrial solid waste through beneficial reuse as raw materials in line with the zero waste and closed-loop material flow concept. This aids to reduce the pressure on demand and landfill facilities or industrial storage for the solid waste. Economy impacts related to the production of BLMIW as an alternative and cost-effective construction material has the potential to generate new economy return. Furthermore, with direct CO2 utilization, the cost and energy requirement associated with CO2 desorption and storage can be saved. Lastly, the cost of solid waste disposal can be reduced. So what is the use of lime mortar? Lime mortar is used in the conservation of building built by lime mortar itself and also as an alternative to ordinary Portland cement. Conventional lime mortar is made of water, lime and sand. The carbonation of lime mortar with atmospheric CO2 produces calcium carbonate, which binds the sand to form the lime mortar. CO2 uptake in this reaction is limited by the contact area and also the CO2 diffusion rate. With that, I will now let Emily present her presentation for the project activities.
Hi, I'm Emily. Now I'm going to talk about the project activities to solve the problems that shared by Alisa. In this project, three innovative approaches are taken. The first approach is replacing water with bicarbonate solution generated by an accelerated weathering of limestone process. In AWL, limestone absorbs carbon dioxide to produce bicarbonate solution. It is a low-tech strategy that is not costly. Current applications discharge the bicarbonate effluent into the ocean to combat ocean acidification. Using bicarbonate solution to replace water provides not only carbon but calcium to form lime mortar. This diagram shows the absorption tower setup. It uses calcium carbonate pellet as the packing with influence of compressed air and distilled water. In our project, ambient air with a concentration of CO2 of 0.04% was used instead of flue gas CO2 concentration around 3 to 20%. The operating condition hence is for direct air capture condition at 25 degrees Celsius and 1 atm. Future work is planned to utilize post-combustion CO2 concentration and condition. This work therefore is a proof of concept of the proposed idea having the condition at extreme low. Reported AWL CO2 capture efficiency in literature is greater than 90% using the flue gas at post-combustion absorption condition. The second approach is replace lime with an alternative calcium oxide source from industrial waste. Cement kiln dust, a byproduct from cement manufacturing, was used in this project because of its high CaO content at 62.8% by weight, compared to industrial metal slag which contain 20.9% of CaO by weight. Both sources produce 220 to 400 million tons annually. Calcium oxide reacts with the bicarbonate solution to carbonize metal to produce calcium carbonate that binds the sand to produce lime mortar. This ensures stable sequestration of CO2 in the construction material. Thirdly, additional industrial waste with cementitious and pozzolanic characteristics are introduced. In this project, fly ash, which is a byproduct from power generation, are used. They function to improve the strength property of lime mortar. Fly ash has been successfully used in applications such as replacement of Portland cement, which achieve comparable strength at later age. This diagram shows the metal carbonation setup. Mixture of CKD, fly ash, and sand are compressed in the mold and is placed between two plaques for the metal carbonation process. The bicarbonate solution is introduced through the various injection points. The percentage of fly ash addition used was 3 to 7%. CKD is used to replace lime to achieve 5 to 25% of CaCO3 precipitation content. Now I would like to pass the presentation to my teammate Sylvester.
Thank you, Emily. Proceeding to the project outcome, this section discusses three main results. First, the CO2 absorption and capture efficiency. The AWL process for direct air capture gave an average absorption efficiency of 31.74%. This efficiency is pale in comparison to post-combustion efficiency of more than 90 and 97% respectively. This is attributed by the higher CO2 concentration of flue gas compared to ambient air. The calcium carbonate absorption capacity obtained experimentally is 0.61 kg carbon dioxide per kg calcium carbonate, which is higher than that of literature, which is only 0.44 kg carbon dioxide per kg calcium carbonate. Also, the bicarbonate concentration achieved in direct air capture is 111.77 mg per liter, with no carbonate ion present. Next, we look at the strength of bicarbonate lime mortar with industrial waste. It is shown that typical lime mortar shows an inferior unconfined compressive strength compared to bicarbonate lime mortars. This is due to its slow carbonization of calcium hydroxide with air to form calcium carbonate. Bicarbonate lime mortars exhibit higher strength because of the use of bicarbonate solution, which provide both calcium and carbon source for its precipitation. Bicarbonate lime mortar with 30% industrial waste shows a comparable strength to bicarbonate lime mortar, as both samples gave similar CaCO3 content. Next, last we present the metal carbonation efficiency. The precipitation conversion efficiency shows an excellent result of 82.09% to a maximum of 91.1%. Provision of an illiquid metal source from industrial waste allow high conversion to its desired metal carbonate to form the binding between the sand particles. To have an idea on the potential of this project, a simple evaluation using a mid-size power plant characteristic was conducted. Based on the calculated result, up to 867 million kg of carbon dioxide can be captured annually. Also, the annual potential utilization of solid waste such as CKD and fly ash can be amounted to 1.76 billion kg and 309 million kg respectively. A plus side, up to 4.4 billion kg of bicarbonate lime mortar with industrial waste can be produced for construction purposes. Moving on, to ensure ability for project industrial scale up, two future studies will be undertaken, consisting of project optimization and techno-economical study. For process optimization, involve the optimization of all process key parameters that impact the AWL process, mineral carbonation process, and mortar curing by the design of experiment DOE software. The interrelation between factors will be established to derive the optimized process condition for industrial scale-up. For the techno-economical study, a four-level hierarchy approach will be implemented. It involved an in-depth analysis of the input-output structure, process flow structure, heat integration, and economic feasibility of the proposed method. This result will be benchmarked to the conventional method to determine its feasibility. This ends our presentation, and thank you for your attention.
Thank you, Team SG20A033 for your presentation. And we shall proceed to the next team. I shall call upon Team SG20A026 from University Science Malaysia to start teaching on their project. Please welcome.
Okay, good afternoon, judges, committees of SEA-GIC 2020, audience. We are from University Science Malaysia, and presenting our project titled Next Generation Carbon Capture and Storage Chemical Looping with Oxygen Coupling, CLOU. The world is facing the challenges of climate change. The main driver of climate change is the human emission of greenhouse gases. Of all greenhouse gases, carbon dioxide contributes to more than 81% of the total greenhouse gases. And the most important activity contributing to emission is burning of fossil fuel. The National Energy Agency assessed that the carbon dioxide emitted from coal combustion is responsible for over 0.3 out of 1 degree Celsius increase in the global average temperature. Southeast Asia overall energy demand has grown over 80% since the year 2000. This results in an increasing trend in annual carbon dioxide emission, with a total of 33.13 billion tons in the year 2018. However, the dependence on fossil fuel for power generation, at least in Southeast Asia, is still rising, as it is a more secure, more affordable, and more sustainable source. Renewable energy in our region only meets around 15% of the region's energy demand. Thus, multiple technologies and approaches are made to capture, transport, and store carbon dioxide produced by these coal power generators. This is known as carbon capture storage, CCS. Okay, one of the chemical looping combustion, CLC. This process produces energy via unmixed combustion, harnessing carbon dioxide emitted by creating a chemical loop between an air reactor and a fuel reactor. Oxygen carrier, typically metal oxides, selectively transport oxygen from an air reactor to the fuel reactor to fully oxidize the fuel. There is no actual mixing fuel and for combustion to occur. The oxygen carrier would circulate in a loop between these two reactors. CLC produced gases are ideally consist of only carbon dioxide and water and are free of diluting species, allowing subsequent water condensation, compression, and the storage of carbon dioxide. Conventionally, traditional CCS technology require gas separation unit to either absorb carbon dioxide in pre- and post-combustion method or to purify air in oxy-fuel combustion method. CLC, the energy penalty of adding gas separation unit is removed, as it inherently prevents the mixing of carbon dioxide with diluting gas species like the nitrogen gas.
Thank you, James, for the detailed explanation on the CLC. But we have something better, which is called chemical looping with oxygen uncoupling, CLOU. Let's focus on the fuel reactor. The solid coal produce chars and release volatiles under the high temperature. The volatiles could directly react with the oxygen carrier, which is the OC, but the char needs to undergo gasification to be able to react with OC. If we choose the OC, they have the ability to release the oxygen. The solid fuel could directly combust with it without undergoing the slow gasification process. In this sense, the gaseous fuel reacts not only with the molecular lattice oxygen on the oxygen carrier, it also reacts with the direct oxygen released by the oxygen. This is a combination of heterogeneous and homogeneous combustion reaction. Unlike under the CLC condition, the only lattice oxygen is available for the oxidation reaction. That is only gaseous fuel combusted using the heterogeneous solid gas reaction. In general, the OC for CLOU needs to have special characteristic and needs to react reversibly with the gas phase oxygen under the high temperature. This places special thermodynamic and kinetic demands on the OC, which are not needed in CLC. The OC for CLOU must have the ability to react with both oxygen from the air to fuel reactor and release this oxygen to decomposition in the fuel reactor. Thus, the CLOU utilizes the fact that some metal oxide have a suitable partial equilibrium partial pressure of the gas phase oxygen at a high temperature for combustion. Some metal oxides based on copper, manganese, and cobalt have this distinctive property and we'll discuss soon. The oxidized form of copper is copper 2 oxide and it will be reduced to copper 1 oxide. Copper-based material show both high reactivity and oxygen transfer capacity. and their relatively low cost and low toxicity make them an attractive choice as OC. Also, sulfurous impurity in the fuel do not significantly affect the performance of copper-based OC. Look at this graph. It is undeniably that the copper oxide is the best oxygen carrier candidate, where it shows the highest oxygen carrying capacity among all. Every single gram of copper oxide could cope with 0.1 gram of oxygen from A to fuel reactor. In this same graph, there are also cobalt and manganese-based OC, but their performance are not as good as copper-based OC. Even though the attention is on the copper-based OC, it is unlikely to get a pure copper, as in the copper ore. If it does, it requires expensive cost to manufacture it. So, researcher has found an alternative way to mix the copper oxide with other elements, resulted the CuAl3O4 and CuMn3O4, to reduce the expensive cost of manufacture a pure copper oxide. However, these two candidates are not able to have a such superior oxygen carrying capacity as pure copper oxide. To wrap up, copper 2 oxide is undoubtedly the best candidate oxygen carrier in CLOU.
Thank you, Yongxin, for the explanation on oxygen carrier. Moving on with the comparison of CLOU with other methods of coal power generation. Let us look at this graph. This is the net electrical efficiency obtained from Aspen Plus simulation. Net electrical efficiency is calculated by dividing the net electrical output with the lower heating value of coal. From this graph, we can clearly see that the conventional methods of carbon capture, which are oxy-fuel combustion and pre-combustion, have the lowest value of net electrical efficiency, followed by coal direct CLC, which is discussed by James just now, and also integrated gasification combined cycle CLC, which is a hybrid technology. However, from here, we can see that CLOU exhibits a significantly higher net electrical efficiency, as high as 48.07% when compared to other existing methods. Next is the economic considerations for the scaling up of a CLOU plant. According to our rough estimation and calculation, for a 100 megawatt CLOU plant, which can cater to 300 homes, the net profit after tax is 78 million euro per year. However, the profit is solely based on the electricity tariff in Europe, along with its operating costs and data. For the construction of plants, we estimate the return of investment, ROI, which is the performance measure to evaluate the potential return and the efficiency of an investment. The ROI of the CLOU plant is 35.8%. The payback period, which is the amount of time needed to recover the cost of investment, is approximately 3 years. This economic data results in high ROI and low payback period. But remember, this is just a small-scale plant with the capacity of 300 homes, and the calculation ignores the time value of money. How about the carbon emission of this CLOU technology? Let us take a look at the specific carbon emission. It is a measure of carbon dioxide released into the atmosphere per unit energy produced. Data from Tenaga Nasional Berhad, which is Malaysia's largest energy provider, shows that the carbon dioxide emitted per unit energy produced from this plant is 540 kg per megawatt hour, whereas the oxy-fuel combustion from the simulation has the measure of 70.69 kg per megawatt hour. However, this is nothing when compared to coal direct CLOU. With CLOU, we can go as low as 1.05 kg per megawatt hour, which is a few hundred times lower when compared to TMB. Although this does not reflect the real scenario, as this is just a simulation, this shows the potential and sets the upper bound of what CLOU is capable of doing. That's all for our presentation. Thank you.
Alright, thank you Team SG20A026 for your presentation.